Hello everyone, good evening. Hi everyone, how are you? Hello. Good evening everyone. I hope I'm audible to everyone, right? Hello, yes. Good evening everyone, good evening. Good evening, Miss Incognito. So you are using your phone in incognito mode, right? Good evening. There is no bicep what to flex, man. And there is no bicep. Okay. So in today's class, we are going to solve few problems from the last class, which was about percentage composition. So I'll quickly revise the percentage composition for you guys. Okay. So we'll quickly go through it and we'll solve few more problems and then we will start with the next topic. Okay. So in the last class, we saw the percentage composition, right? So what was percentage composition? So as I told you, I'll just quickly go through it once. For example, as I told you, let us say some 200 people are sitting over here, right? 200 people are sitting, including me. Or let us say Rohit Sharma. Okay, take the Rohit Sharma here. So if Rohit Sharma is there, right? And you want to know what is the percentage composition. When I say percentage composition, I'm talking about percentage by mass, okay? I'm talking about percentage by mass. So let us say we want to know that what is the percentage composition of Rohit Sharma among total 200 students. So because it is percentage by mass, so what will write? Mass of Rohit Sharma, isn't it? And because Rohit Sharma is a number, only one number is there. So mass of Rohit Sharma into 1 divided by total mass. Total mass of 200 people, isn't it? Total mass of 200 people multiplied by 100. So that will be percentage composition of kiska percentage composition? Rohit Sharma, isn't it? So if Rohit Sharma ka mass is, let us say 20 kg, right? If it is 20 kg and let us say total mass of the 200 people is 2000 kg, so this is the percentage composition of Rohit Sharma. Right, so this is very easy, percentage composition, and with the help of percentage composition, we try to find out the empirical formula and molecular formula, isn't it? With the help of percentage composition, we found out what is empirical formula and molecular formula. So if you remember the empirical formula, what was empirical formula? So in case of empirical formula, molecular formula, there was one difference. What is the difference? In case of molecular formula, let us say we are having ethane molecule, okay? So C2H6, right? So if you have ethane molecule, that is how the ethane molecule exists. Actually, that is how it exists. So in ethane molecule, there are 2 carbons and 6 hydrogen atom, right? And you come to the simplest ratio, that is CH. So this will be 2,3. So this is CH3. So this is the empirical formula of the ethane and this is the molecular formula of ethane, right? So this was the difference between empirical formula and molecular formula. It is about simplest whole number ratio, and then we solved a lot of problems, right? So let us come to one more problem we will be having over here. Okay, everybody go for this problem. Let us solve this problem. Ascorbic acid, which is the major component of vitamin C, ascorbic acid also known as vitamin C, which cures scurvy. It is composed of these many percentage of carbon, and this is the percentage of hydrogen, and this is the percentage of oxygen given. Determine its empirical formula. Kind of. Empirical means you take the simplest ratio, common numbers se divide. So that will be the simplest ratio. Please solve for this one. Give me the empirical formula for the ascorbic acid, guys. Let's see. Empirical formula for the ascorbic acid. Empirical formula for the ascorbic acid. Please solve it, everyone. Let's see how many of you can do empirical formula of ascorbic acid. Is anybody solving? Give me thumbs up. Let's see. Ascorbic acid is vitamin C. You have to find the empirical formula. Give me thumbs up. Let's see how many of you are solving, so that I can know that some of you are actually solving or wasting simply time over here. Most of you are just simply doing the time pass over here, right? How many of you are solving? Let me see. Then only we can stick to the problem. Okay. Okay. Some of you are solving. Okay. Go ahead, beta ji. Please solve it. What will be the empirical formula? H2O2. Do that, please. Go ahead. Solve it. So, how we start the formula is, first what we write is elements, right? The elements. What are the elements we are having, Bolo beta ji? Carbon we are having, hydrogen we are having, and we are having oxygen, right? So we are having 3 elements, and then we assume total mass to be 100 gram. So if we assume total mass to be 100 gram, percentage itself becomes mass, right? So what is the mass we are having? Mass we are having is, for carbon we are having 40.92. The percentage composition will actually become mass, right? C3H4O3. Okay. Jasnavi has the C3H4O3. Okay. So most of you are getting C3H4O3. Anybody else? Let's see. Okay. So let's check. So carbon this much. Hydrogen ka percentage is given how much, Bolo beta ji? 4.58. And what is the remaining one? 54.5% is of oxygen, right? Now, once we have percentage, what we find? This is 9.2, right? So, the next one, we go for moles, right? So, we will find moles. So, how to find the mole? 40.92 by 12, right? Similarly, 4.58 by 1 itself, so that is the mole itself, and this is 54.5 by 16, right? So what is the mole coming over here? 40.92, what will be the exact moles over here? C3H4O3, we are looking into that. Let's see. So 40.92 by 12, the value is 3.41, okay? So this value is coming 3.41. This is the number of mole of carbon we are having, okay? And the next one is hydrogen, which is already 4.58. 54.5 by 16, exactly what value we are getting is 3.4, okay? So we are having 3.4. Now what I told you other day, what I told you, Bolo beta ji, what I told you, that divide by the simplest mole, isn't it? Divide by the simplest mole. So what is the simplest mole? 3.41, right? So if I divide by the simplest one, mole ratio, we are talking about mole ratio. So this will be 1, of course, this is approximately 1, and 4.58, let's see what is that value, divided by 3.41 gives us 1.3, this is 1.34. Okay. So this is 1.34. Now I have to multiply by a number because I want the whole number, right? We want the whole number, therefore we will multiply by a number. So if I multiply by 1.3 into 3, 1.3 into 3, so this will be 3 3s are 9, and this will be 314, right? So this will be approximately 4.9, that means 5. So we should multiply by what number? We should multiply by what number? Tell me. I should multiply by what number? If I multiply by 3, this will be 3, and this is 3, and this will be approximately what? This will be approximately 5, isn't it? If you multiply 1.34 into 3, what is the value approximately coming? So 1.34 into 3 comes out to be 4, sorry. So this is coming approximately 4.02, some value is coming. So now we have the mole ratio, and we multiplied by a simplest number. I have multiplied by a number so that we have a whole number ratio. So what is the formula? C3H4 and O3, right? So this is the empirical formula. This is not the molecular formula of ascorbic acid. Why only 3? Okay, somebody is having doubt. Sir, why are you multiplying only by 3? Okay, so that doubt should not occur. But anyways, I'll tell you. Dekho beta ji, everyone, Why I am multiplying by 3 is because I look at the number and I get the idea that if I multiply by 3, 13 into 3, 3.9, right? So approximately we will get the 4 value. Why only 3, Satvik? Let us look at here. You want a whole number, right? We want a whole number. Because we want a whole number, therefore I need to multiply by such a number which gives a whole number, right? So I will be looking at the values. This is anyway 1 and 1. This is anyway whole number. Now through what number I should multiply? I'm thinking 1.3. If I multiply by 3, 1.3, 13 into 3 is approximately 39, right? So 3.9. Approximately I am getting 4. I'm getting 4 value, right? So this is 4. Therefore, this is C3H4O3. This is not the exact formula of ascorbic acid, vitamin C. This is not the exact formula, but this is the empirical formula. It can also be 2. Beta ji, if you multiply by 2, 1.3, it will become what? 2 3s are 6, 2 1 2. That will be 2.6, isn't it? 2.6. Is it a whole number? That is not a whole number. If you multiply by 2, that is not a whole number. You need a whole number. Okay, great. So this is the formula. Just give me a thumbs up, guys. Let's see if you have understood this. Should we move to the next problem? Is it clear to everyone, guys? Give a thumbs up. Let's see. Is it clear to everyone? Bolo beta ji. 4.02. Yes, 4.02, which is approximately 4. 4.02, which is approximately 4. 4.02 beta ji, which is approximately 4, right? Okay, so let us move to the next problem now. Okay, very easy. Calculate the number of grams. Calculate the number of grams of aluminium. Okay, this you can do. Mole concept question is there. Okay, so we are having this compound. A sample of a compound containing boron and hydrogen contains 6.44 gram of boron and this much of hydrogen. The molar mass of the compound is about 30 gram. Okay, now you see they have directly taken the mass. Now it is not percentage. Yes, mole ratio. Yes, mole ratio. You have taken mole ratio there. Now, in this case, okay, go ahead for this one, beta ji. So now we are not having percentage composition. In a given compound, you are directly given what we are giving, bolo beta ji, mass. 6.44 gram of boron and 1.83 gram of hydrogen. So directly they have provided the mass. So you can directly go for the moles. Right? There is no percentage composition over here. Go ahead. Please solve this, everyone. Go ahead, beta ji, solve this problem. Go for this problem. Let's see. Please solve this. Some of you should give the answer. Let's see what answer you are getting. Go for it, beta ji. Go for it. Not understanding? Anybody is able to solve, or I should solve the problem? Anybody? Okay, I'll solve the problem. No problem. Okay, so let's see. So we are having carbon hydrogen. Now see, one step is easier now. So, sorry, carbon, no? Boron, right? So we are having boron over here, and because we are having boron, mass is directly given to us. What is the mass given? 6.444 gram is given, and mass of hydrogen is given 1.803. So generally what we are doing is we are trying to B2H6. Okay, let's see. We'll check better. So generally diboron, that is very famous compound, B2H6. So I think that will be correct. So BH we are having, so mass is directly given. So why to go to the mole percentage? Mass percentage. Already we are having the masses, right? So directly I will go to the mole now. So mole 6.444. I think boron ka mass is approximately 11. Exact mass is 10.8 something. Approximately we can go for the 11. Okay. And then hydrogen ka mole will be anyway 1.803 by 1. So that is the mole. So if you divide this number, what value we are getting? If you divide 6.444 divided by 10.8, approximately it is 6. So this is coming out to be 0.6. Okay. So this is approximately 0.6 and this is how much? 1.8. Now this is the mole ratio, beta ji. This is the mole ratio. Now what we do is once we have this value, what we want to have? We want to have a whole number ratio, right? So therefore dividing by the smallest value. What is the smallest value? 0.6, isn't it? So divide by 0.6. So if you divide, we will have the mole ratio. What is the ratio we are getting? 0.6, here aa gaya 1. This is 1.8 by 0.6, isn't it? So this is equal to 3. So we are having 1, 3. So what is the empirical formula? Empirical formula is BH3. This is the empirical formula. This is the empirical formula. Now question is about finding the molecular formula and mass is given. So we remember how to find the N value. How to find the N value? Molar mass by empirical mass. Molar mass by empirical mass. So what is molar mass? 30 grams. And what is empirical mass? Can you give me the empirical mass? So this is approximately how much? 11. And hydrogen ka mass is how much? Bolo beta ji? 3. So this value comes out to be, so 11 plus 3, it comes out to be approximately 14, right? So N value, so molecular mass by this value, if you calculate, so 30 by, what is the value? 14. So we are approximately getting 2, right? So N ka value 2. That means BH3 ka whole twice, which is equal to B2S6. Very good. So most of you have got B2S6. Most of you have got B2S6. So that is correct. Most of you are getting B2S6. Very good, beta ji. Very good, all of you. B2S6, very good. Is it clear? Should we go to the next problem? If anybody is having doubt, let me see. Otherwise, we'll go to the next problem. Just give me a thumbs up. Let's see. Is it clear to everyone? Should we go to the next topic now? Should we go to the next topic? Okay. Okay, guys. Chalo, let us go to the next one now. Okay. So we are having, this is very good problem actually. Let us see how many of you can solve. What is the molecular formula of a compound containing only carbon and hydrogen if combustion of 1.05 gram of the compound produces? So there is a molecular compound which contains only carbon and hydrogen. Containing only carbon and hydrogen. And if you do the combustion, we all know what is combustion. Combustion will produce what, bolo beta ji? CO2 plus H2. Because the compound contains only carbon and hydrogen. So that is the problem given. And what is the mass of the compound? Combustion of 1. So this hydrocarbons means that compound which contains only carbon and hydrogen, right? So this hydrocarbon ka mass is given 1.0. We don't know what is the hydrocarbon, that we have to find. So this is not given. Of the compound produces this much mass of carbon dioxide, which is 3.3 grams, and mass of water is given to us, which is 1.35 gram, and then its molar mass of the compound, molar mass of the hydrocarbon is given 70 gram. So we have to find the empirical formula, molecular formula. Okay, so we have to find the molecular formula. Go for it. Let's see. Let us see if you can find. Is anybody going to try, or I should solve it? Anybody, just give me a thumbs up. Is anybody going to try, or I should go with the problem? Bolo beta ji. Some of you are going to try. Let's see. Quickly give a thumbs up. Let's see if anybody is going to try the problem. Okay, please go ahead. I'm giving you 2 minutes. Please solve this problem. Let's see how many of you can solve this. Chalo beta ji, go ahead. Okay, Lakshmi, solve the problem. Let's see. Please go ahead, go ahead. Solve the problem. You are having 2 minutes. Please solve this. Let's see how many of you can do it. Solve karo beta ji, solve karo. So there will be 2 ways to solve it. Actually, in the first way you can find the moles, but I won't go through that process. That is a lengthy process. I'll go with a much simpler process. You can go with the mole. First you can find the mole and then you can solve the question. N is equal to molar mass by empirical mass. Yes, Yes, Naruto, yes. Molar mass by empirical mass. Let's see, anybody is getting the answer? How to do it? Should I solve? Just say yes sir, I'll solve the problem. If all of you want me to solve, just say yes sir, I'll go with the problem now. Okay, I'll go. Chalo. No sir. Chalo, one more minute. Quickly finish it. If you are solving, 1 more minute. Okay, I'll do. Chalo, I'll do. Now, we are having carbon dioxide. So, I'll go with alternate method. Generally, if you will look into the books, there is one method. But I won't go with that method. I'm going with the different one, which is actually simpler one. So, if you look at the carbon dioxide, let us say we are having 1 mole of carbon dioxide. So 1 mole of carbon dioxide ka formula, 1 mole of carbon dioxide contains how much mass below beta ji? 44 gram. So 1 mole carbon dioxide has 44 grams, right? Isn't it? So if you see in 44 gram of CO2, what is the amount of carbon present? In 44 gram, carbon ka amount is 12 grams, isn't it? 12 gram of carbon. Very simple. See, my whole approach is to find the mass of carbon and hydrogen. If I somehow find the mass of carbon and hydrogen, we all know law of conservation of mass, that whatever mass is coming over here, same mass will be for CH. Mass will not change. But to have the empirical formula, I know for the elements, either I need percentage composition or I need mass. Once I will have masses, I can have the moles. And then only I can go for the empirical formula, right? So my first responsibility is to find the mass of carbon and hydrogen. So if you look at this, this is 1.05 grams hydrocarbon. But in this 1.05, what is the mass of carbon and what is the mass of hydrogen? That I need to find with this value, C5H10. Okay, will come. So 44 gram of CO2 gives 12 gram of carbon. Some of you are getting C5H10. We'll see. So now, how much carbon dioxide do we have? 3.3 gram, isn't it? So 44 gram contains 12 gram. So 3.3 grams of carbon dioxide will have how much? So this will have 12 by 44 into 3.3, right? 3.3, isn't it? So this is how much? 4.3. This is 11, right? So 11, kitna ho gaya bolo beta ji? 33. So 0.3. So this value comes out to be 0.9 gram. That means 3.3 gram of CO2. Please understand, if any one of you are having doubt, let me know. 3.3 gram of CO2 will have 0.9 gram of carbon, right? So 3.3 gram of CO2 will have 0.9 gram. Isn't it? 0.9 gram. Same thing I have to do for hydrogen. Now let us go for hydrogen. Actually, you can directly find what is mass of hydrogen. So that is very easy because total mass is 1.05. See, mass of hydrocarbon. CH ka mass is how much given? 1.05 grams, isn't it? And we have just now found the mass of carbon. Mass of carbon is 0.9. If you subtract, what you'll get? 0.15. What is 0.15 gram? So this is nothing but mass of oxygen, isn't it? This is mass of oxygen. Or you can go with another way. You see, water ka mass is given 1.35. So water ka mass is given 1.35, right? I want to know the mass of hydrogen. Again, we know 18 grams, that is 1 mole. 18 gram of water has what mass of hydrogen? 2 into 1, 2 grams of hydrogen. 2 grams of hydrogen. So 1.35 grams will have how much? So this will be 2 by 18 into 1.35, isn't it? So 2, 9 and 9, I think, how much? 15, right? So this will be 0.1. Or you can directly do it here because total mass is given 1.05. So this will be 0.15 gram of oxygen. So now what I have find is, kya aa gaya hamare paas? I am having values of carbon and hydrogen. Mass I have. What is the mass of carbon? Mass of carbon 0.9. And what is the mass of hydrogen? This is 0.15, right? So now I have this value. What to do next? Find the mole ratio, sir. Find the moles. So if I find the moles, so 0.9 by 12, 0.9 by 12. And for this one, 0.15 hydrogen is 1. So what is value? Kitna aega? So this is 0.075. This is 0.075 and this is nothing but 0.15, isn't it? Okay, I'll rub this one, okay? I think this is clear to everyone. Yes? Okay, so now what will be the mole aa gaya hamare paas. Now once I have the mole, what to do next? Once I have the mole, what I'm going to do is find the mole ka ratio, isn't it? Find mole ratio. How to find mole ratio? Divide by the simplest number. Divide by simplest number. What is that? 0.15. So 0.75, right? So this is 1 and this is 0.15 by 0.075, right? So 0.15, this will be approximately how much? I think 3, some value will come, right? So 0.15 divided by 0.075, this is 2. This value is coming out to be 2. Now once we have the mole ratio, now this is very easy, isn't it? So what is the mole ratio now? Mole ratio CH2, 1:2. So now I have the empirical mass. What is the empirical mass? Bolo beta ji. This is the empirical formula. Now I have to find the molecular formula. So empirical mass is equal to, bolo beta ji kitna ho gaya? 12 plus 2, 14. So 14 gram. Again, what is the n value? What is the n value? Molar mass. What is the molar mass? 70. And what is the empirical mass? 14. The value comes out to be 5. That means CH2 ka whole 5, it will give us what, bolo beta ji? C5H10. Right? C5H10. I hope this is clear to everyone. Give me a thumbs up. Let's see. Is it clear to everyone? It was a good question. This kind of question has been asked in mains so many times. Is this clear to everyone? Give me a thumbs up, guys. Let's see. Is it clear to everyone? Bolo, this problem. Clear to everyone? Let's see. C5H10. Everybody understood? Everybody understood? Very good, Yagnasri. Okay, very good. Very good. Very good. Okay. Now, coming to the next problem. We'll go to the next problem, right? Okay. So, a sample, you can try this later. That is similar problem that this we have done already. This we have done. This we have done. Okay, you can try this one. Let's see, do I have any good problem over here or simple ones only? Do you want to try any more or should we move to the next topic? Now, we'll go to the next topic, okay? Let's see if we have any good problem. You can try these problems. These are very easy problems, okay? Okay, you all know caffeine, right? Just quickly, very easy problem. I'm giving you very, very easy problem. Just solve it. This is the last question. We'll go to the next topic now. The molar mass of caffeine. You all know caffeine, right? Caffeine is found in? Bolo, coffee. Yes or no? Quickly do it. So the caffeine ka molar mass is 194.19 gram. Is the molecular formula of caffeine? Which is the molecular formula? Simply add the values. Let's see. Quickly, bolo beta ji, which is the molecular formula? Which is the molecular formula? Quickly. Very easy problem. Quickly, go for it. Let's see. Give the answer. C8H10N4O2. Okay. Yagnasri has got the answer. Anyone else? Let's see. Let's calculate the mass. So 12 into 4 plus 5, 1 into 5, nitrogen, 14 into 2 plus, what is the oxygen? 16. I think very clearly you can see this mass will not add up to 194. You have to multiply by 2. We'll check. So this is 48 plus, bolo beta ji, 14 to 28 plus what? 16 plus 5, right? So definitely this value is not sufficient. So if you multiply by 2, this will be the molecular formula and this will be the mass. I think very easy, right? Very, very easy. So the molecular formula will be C8H10 and 4O2. Yes or no? If you multiply by 2, that will be the molar mass. That means this is the molecular formula, this is the empirical formula. This formula is the empirical formula and this one is the molecular formula. This is the molecular formula. I think very easy, all of you have understood. Now, we are going to the next topic now. There are a few more problems, Betaji, you can try. Definitely, these are very good problems. For example, allicin is the compound responsible for the characteristic smell of garlic. So that smell you have in garlic, right? That smell is due to allicin compound, and again percentage by mass is given. Through that you can find the molecular formula. We have done that already. Similarly, so many questions are there, you can try. I think this is the last. Okay. So we are starting with the next topic now. We are going to understand what is called as redox reactions. So starting with the new topic, just guys, focus everyone. We are going for the next topic, just gear it up. Let's see how much of this we can understand. Again, redox reactions are very, very helpful. Throughout the chemistry, it will be used at so many places. As I have told you, we are choosing all those topics which have high importance. Redox reactions we will do the calculation and finding out oxidation numbers, what is oxidation, what is reduction, very basic idea you already have in your high schools, oxidation, reduction, what it is. Or we'll try to cover up those concepts and make you more comfortable in calculation of the oxidation numbers, how to check the oxidation reduction, what are the oxidizing agents, what are the reducing agent. So it's a huge topic, entirely used everywhere, used in physical, organic, inorganic, very, very important, right? So before we start for the redox reaction, I want to go through something which is known as electronegativity ka concept, okay? So before I go anywhere else, let me discuss a concept which will help us a lot, to understand how to find the oxidation numbers. What is Z effective, sir? I have written Z effective. What is Z effective? Z effective is called as effective nuclear charge. Z effective is called as effective nuclear charge. So before I start with the redox reactions or redox numbers, I want quickly go through effective nuclear charge and electronegativity. Okay. So anybody can give me the definition of electronegativity? Anybody can give me the definition of electronegativity? Any one of you, please? Let's see. Can you give me the definition of electronegativity? Anyone? Electronegativity definition. Give me the definition of electronegativity. Let's see how many of you can give that. Okay, so I'll start. So what is the electronegativity ka concept? Dekho. So to define electronegativity, I need to understand what is effective nuclear charge. Listen to the class. I'm going to tell very interesting concept. Let us say we are having a nucleus over here, and let us say these are the orbits in which electron is present, which is revolving around the nucleus. What is effective nuclear charge? Listen carefully. So if I'll ask you, what is the number of electrons? So let us say in second orbit, first orbit 2 electrons are there. In second orbit 8 electrons will be there, yes or no? 5, 6, 7 and 8. Similarly, if you go to the next one, so again we have so many electrons, right? 8 electrons like that. Now, what is effective nuclear charge? You see, the term itself says that what is the nuclear charge which is effective for a given electron. Effective nuclear charge means for one electron, a given electron, let us say I'm calling this as testing electron. What is testing electron? For this electron, I want to measure what is the actual charge it is going to experience. Let us say that I'm having sodium atom. What I'm having, bolo beta ji? Sodium atom. We all know in sodium there are 11 electrons and 11 protons, and it is a neutral atom, right? Now, if you look at this electron is attracted to the nucleus. This electron is attracted to the nucleus. As well as this electron is also attracted to the nucleus, this red one. So this red one is attracted and this blue one is attracted, both are attracted. Now my question is, which is experiencing more attraction? So what I did is, I started to ask every electron. So I'm asking this electron, hey bhai electron, tum batao. This electron I'm asking, bolo bhai, how much experience you're having for the plus charge? So this electron jumps and becomes very happy. Kya bolte electron? Sir, I'm having full experience of positive charge. I said, what it means by full experience of positive charge? It says that, sir, see, there are 11 protons in the sodium atom, right? 11 protons in the nucleus, right? So I'm able to experience all the protons. Okay, very good. I was like, why you are able to experience every proton? Because it says that, sir, see, between me and the nucleus, there is nobody. There is no electron which is going to remove my attraction for the plus charge. So I'm very close to the nucleus. Because I'm very close to the nucleus, I will have full attraction. So, iska effective nuclear charge is actually nuclear charge. Effective nuclear charge for this electron, is full. Full is what? What is the charge? 11. So this electron, the first electron, is able to experience all the 11 protons. So effective nuclear charge is the nuclear charge. Effective nuclear charge is the nuclear charge because it is able to experience effectively 11. It is able to experience, this electron is able to experience all the 11 protons. It is very happy. Now, I am going to the next one. So now, I am going to ask these blue ones. Okay. Chalo, let me ask this one. Okay, let us change some paint so that you can understand. Okay. So now I am going to the second orbit and let us say I am going to ask this electron. Okay. I am asking this electron, hey bhaiya, how much you are experiencing nucleus? This electron became little bit unhappy. I said, what happened? Sir, I am not able to experience all the 11 protons. Why? What happened? Sir, you know, because the nature of charge I am having is negative. The nature of charge I am having is negative. And this electron which is side by my side, it is giving me repulsion. This is giving me repulsion. This is giving me repulsion. Sir, I am experiencing the repulsion. So I asked this electron, are you experiencing the repulsion from the outer electron? It says, no, sir. I have no problem because this is me and this is the nucleus. So whatever electrons are present inside, between me and the nucleus, they are giving me the repulsion. I am not worried about the outer one. Outer one will be actually, I will be kicking out outer ones. I have no problem with the outer one. My problems are these inner electrons. So they are repulsing me. They are repelling me. They want me to go away. So I said, what happened with you then? Sir, I am able to experience less positive charge. I am not able to experience all the 11 positive charge. I said, okay, no problem. What to do? This is the life. This is how it happens. Because it is away from the nucleus, it will experience certain repulsion from the electrons. From the same orbit ka electron will also repel, as well as inner electrons will repel. And therefore, it is not able to experience all the charges. So that is called as effective. So effectively it is able to experience how much? So I'll write effective nuclear charge is equal to, what is the effective nuclear charge? So what is the nuclear charge? Z. Z is the atomic number. Z is the atomic number, which is number of proton. So this is the actual charge. But this electron is not able to experience all the charge. It is having some amount of repulsion. So charge will decrease, right? How much it will decrease? I am saying sigma. How much it will decrease? Sigma. This is called as shielding. What I have already told you, this is called as shielding constant. This is called as what, Beta Ji? Shielding constant. What happened? So these electrons are actually, these electrons are actually shielding. These inner electrons are trying to shield the nucleus. They're trying to shield the nucleus. Why they're able to shield? Because the electron and electron ka charge is same, so it will repel. It will repel the outer electrons. So therefore it is shielding the nucleus. So effective nuclear charge is not the actual charge. Effective nuclear charge is a little less than the actual charge. That is called as effective. Effective means effectively it is able to experience how much charge. That is effective nuclear charge. So, okay, I understood. Now, let us say that if it is the repulsion is there, then why does the orbit complete an octet? And that is different thing, beta ji. That is basically the basis of quantum mechanics, how 8 electron, because that is stable configuration. If you see, that will be 2p6. We have already studied that. So it is a stable configuration. Right now, don't go for that. Definitely, they're stable. It is not like they're not stable. They're stable, but there is certain amount of repulsion. Okay, they're stable, but repulsion is there. Now, I'm going to ask this electron. Okay. Now let us say we are having this particular electron, this blue one. Now I'm going to ask this electron, hey bhaiya, how much you are experiencing? He says, sir, don't ask. My life is in tragedy. I'm not feeling any good. And what happened? Sir, you see, these many electrons are inside. These 8 electrons and 2 electrons. This electron, this electron, this electron, this electron. Every electron is repelling me, sir. Every electron is putting the repulsion. So I'm going away. I'm not able to experience all the plus. I want to experience all the plus, which is atomic number. I want to experience all the plus, but I'm not able to experience because they are putting the repulsions. Right? Let us say you want to get closer to someone. You want to get closer to someone, as most of you are trying. So you want to get closer to someone, but there are certain people which are more closer. What will happen? They will repel you. Go away. Right? So that is inter-electronic repulsion. So due to that inter-electronic repulsion, the attraction you want to experience, you are not able to do that. So effectively how much you are able to do, that is called as effective nuclear charge. And that is called as effective nuclear charge. Okay. So what is sigma? Sigma is the total repulsion applied by the electrons. Sigma is the total repulsion applied by the electrons. So what is Z effective? Effective nuclear charge is equal to actual nuclear charge. This is the actual one. Actual nuclear charge minus all the shielding, means all the repulsion. So if I subtract all the repulsion, then that will become actual nuclear charge, which is known as effective nuclear charge. Actually how much it is experiencing? It is not experiencing all the 11 protons. It is experiencing less than 11. How much less? We are going to calculate with the help of repulsion, which you will do in the periodic table chapter in your 11th class. Anyway, we will have the periodic table later on. But why I am explaining this? Just to explain one concept which is known as electronegativity. Is this clear to everyone? Effective nuclear charge, just give me a thumbs up. Is effective nuclear charge clear to everyone? Give me a thumbs up. Let's see. Is effective nuclear charge concept clear to everyone? Hello everyone, is it clear? Okay. All the people who are sincerely listening to the class, just give a thumbs up. Let's see. Okay. Now, once I've understood the effective nuclear charge, it is independent of distance from nucleus. No, it is not independent. You see, as it is going away, it will have more internal electrons. So as a distance is not a parameter, parameter is the electron. Distance is not a big deal, but because, see, I'm not saying directly it is distance dependent, but because it is going away from the nucleus, there are electrons, more number of electrons will come inside the orbit, so therefore more repulsion will happen. Okay. Now, we want to understand the concept of electronegativity. What happened? It is not moving, huh? What happened? Just wait a minute, guys. Okay. So now we want to understand the concept of electronegativity. Okay. We want to understand the concept of electronegativity. So actually, electronegativity is related with the effective nuclear charge. How it is related? Let us come to that. Let us say I am having second period of the periodic table: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Right? Fluorine and neon. Right? Now, what is happening over here? You see, continuously number of protons are increasing. Continuously number of protons are increasing. Number of protons are increasing, isn't it? Now, you see, we are having a nucleus, first orbit and second orbit. First orbit and second orbit. I'm not going to do the calculation. Actually, you can calculate also. You will see that effective nuclear charge ka value will be continuously increasing. So you have to calculate the sigma value, shielding constant, That will be done in your 11th class periodic table chapter. I'm not going into that. I'm simply explaining with the logics. Okay, I'm not doing the mathematical calculation. This could be observed with the mathematical calculation also. So you see, now we are having the electrons in this particular orbit. Okay, now see, so first orbit has 2 electrons, lithium 1 electron, beryllium 2 electron, boron 3 electron. Now the electrons are coming in the same orbit. The electrons are coming in the same orbit and number of protons are increasing. So number of protons 3, 4, 5, 6, 7, 8, 9, 10. So continuously number of proton is increasing. But the electron is increasing in the same orbit. Very interesting, right? Electron is increasing in the same orbit. Because electron is increasing in the same orbit, it will not have much repulsion. See, electron has to go to the next orbit. If electron goes to the next orbit, now it will experience this orbit ka repulsion as well as this orbit ka repulsion. But for now, because all the electrons are coming in the same orbit, it will not have much repulsion. So proton is increasing continuously, but shielding ka value is not high. Shielding ka value is not high. Shielding ka value will be very less. So if you see Z effective is equal to Z minus sigma, so Z is to continuously increasing. It is increasing a lot. You see one proton, it is increasing. But sigma value is increasing very slightly. Shielding is increasing very slightly and sigma is increasing a lot. Sorry, Z is increasing a lot. So Z is increasing, one proton. But because all the electrons are coming in the same orbit, they are not going to have much repulsion. If electron goes to the next orbit, let us say this orbit, now this will experience more repulsion, isn't it? I hope you understand that. So in that case, sigma also increases, repulsion will increase in the same orbit, but that is very less in comparison to the inner orbits. Repulsion is less. So sigma increases, but this Z value is increasing a lot. Therefore, so this is plus sign and this is minus sign. So overall effective nuclear charge increases. Overall it is increasing. Sigma increases slightly and Z increases a lot in comparison to sigma. Therefore effective nuclear charge increases. So as you go left to right into the periodic table, effective nuclear charge increases. Effective nuclear charge increases. Now what is electronegativity, sir? In a bond, let us say I'm having AB bond, okay? Or let us say I take, which bond should I take? Okay, let us say I'm talking about CF bond, carbon-fluorine bond, right? Carbon-fluorine bond. Right now I'm not concerned with the valency. You forget about the valency, how many bonds. I'm just talking about CF bond. So as you go left to right in the periodic table, effective nuclear charge increases. So which is having more effective nuclear charge, carbon or fluorine? Definitely, sir, fluorine is having more effective nuclear charge in comparison to the carbon. Now, more effective nuclear charge means what? More ability to attract the electron. More nuclear charge means what? More ability to attract the electrons. Effective nuclear charge. Higher the nuclear charge, that means positive charge is high, that means it will be able to attract more electrons. And what is electronegativity? Electronegativity is an ability of an atom to attract the electron in a bonded state. Right? So you see in the carbon and fluorine ka effective nuclear charge is more. Because fluorine ka effective nuclear charge is more, these electron, this shared electron which is covalent bond, these shared electrons will be more pulled. More pulled towards what? There will be more pull towards fluorine. There will be more pull towards fluorine because fluorine ka electronegativity is more. Therefore, you see, this will have a partial charge. This delta is called as partial charge. So fluorine will have partial minus. Why partial minus? Because if it will attract the electron, what will be the charge created? Minus on the fluorine. But it is not exactly -1. It is partial minus because they have not taken entirely the electron. This partial charge ka placement has happened. So this will become partial minus and this will become partial plus. So what is electronegativity? Electronegativity is the ability of an atom to attract electron in a bonded state. What I mean is, let us say if you have an AB bond and you say electronegativity of B is more than A, that means these shared electrons will spend more time towards B rather than A. More charge will come towards B, so B will have partial minus and A will have partial plus. Entirely electron has not transferred, it is not like Na plus Cl minus. In Na plus Cl minus what happens? The electron is transferred from Na to Cl. Therefore, complete plus and minus. There is no complete transfer, there is partial transfer. This is partial plus, partial transfer, so therefore partial minus. Why? Because electronegativity of B is more than A. And why is electronegativity of B is more than A? Because effective nuclear charge of B must be more than A. More effective nuclear charge, that means more plus charge, that means more attraction for the electron. Electron is coming towards me, I will become partially negative, and because I am taking these electrons from the other atom, it will have partial positive. Is it clear to everyone? Is this concept clear to everyone? Just give me a thumbs up, guys. Let's see. To all the students who are sincerely listening to the class, is it clear to everyone? I'm putting too much effort to explain this. Is it clear to everyone? Give me a thumbs up, guys. Let's see. Is it clear to everyone? Concept of electronegativity. Great. Great. Okay. So, whenever you go left to right in the periodic table, whenever we go left to right in what? Periodic table. Whenever we go left to right in periodic table, effective nuclear charge increases and therefore electronegativity will increase. Therefore, electronegativity will increase. Okay? As we go left to right in the periodic table, effective nuclear charge increases, therefore electronegativity will increase. Okay? And as you go top to bottom in the periodic table, effective nuclear charge will decrease. Why it will decrease? Now you see, as I told you, first period, second period, third period. That means electron is being filled in that next period. Next period means next orbit. So first, second, third, fourth, fifth, sixth, like that it is happening. So what will happen? Z effective is equal to Z minus sigma. Now what is more dominant? Sigma. Because the electrons are changing their orbits. Because electrons are changing their orbit, they will have more repulsion rather than attraction. In this case, left to right, period is not changing. Orbit is not changing. But here orbit is changing, so more repulsion will happen. So sigma will be more and Z will be less. Therefore, effective nuclear charge will decrease. So top to bottom, effective nuclear charge decreases. Top to bottom, effective nuclear charge decreases, right? And left to right, effective nuclear charge increases. So top to bottom, what will happen to electronegativity? Top to bottom, electronegativity decreases, and left to right, electronegativity increases. Is this clear to everyone? Just give me a thumbs up, guys. Is this concept clear to everyone? Is it clear? We will go to the redox reaction now. Tomorrow we will start with that. So this is going to be very, very helpful. A lot. We will use this concept tomorrow to explain you the logic, how it is going to help to check the oxidation number. You will love it tomorrow. Seriously, you will love it. Very, very interesting thing will come tomorrow. Does it work in chain? Yes, it works in chain also. It works in chain. For example, you have, let us say, carbon, 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 fluorine. So fluorine will attract. So this will become minus. So this will become plus. Now, this carbon has donated the electron, therefore plus. That means now it has become more electronegative. So this will attract. So it can work in chain. That is also fine. Okay, guys, see you tomorrow. Tomorrow we are going to use this concept a lot to understand redox reactions, to understand the very famous reaction we have studied, displacement reaction and those things. Okay. See you guys tomorrow. Take care. Bye. Okay. Thank you everyone. Thank you. See you tomorrow.